Okay, today we're going to add in trapezoids, rhombi, and kites. And when we do these area formulas, I have to warn you, trapezoid area formula is on there. It's one of the harder formulas, so it's nice that it's on there. The rhombi and kite formula is completely new to a lot of people. A lot of people, this is the first time you found the area of rhombi and kites. Rhombi is just the plural for rhombuses, guys. So when you see this, please be aware that the formula for rhombus and kites, rhombi and kites, is not on your formula sheet. I just looked that up again just to confirm. I want to make sure you know that is not on there, so you will need to know these formulas for the actual test. They are not going to be on the formula sheet. So try to make sure you're really clear about that and highlight those as we go forward. Okay, getting started. As I said, this formula will be on there. The way they write it, because I'm going to try to write it, the way they write it is 1/2 H times, in parentheses, B1 plus B2. 1/2 H times, in parentheses, B1 plus B2. Now, we got to know how to use that formula. Whether or not they give that formula to you on the day of the actual test or not, if you don't know what the things mean, it's not going to make any difference. So, looking at this, when you have a trapezoid, and we've done shapes for, so this is not like a new shape to you. A trapezoid is going to be a shape that has two sides parallel and the other two are not. Okay, the two that are parallel are going to be your bases. The first one is going to be base 2. Doesn't matter if it's on top or bottom, it's just the first one. Whichever one you go to first, that's base 1. And then the other one is going to be base 2. The height is going to be at a right angle to those two bases. So those are the numbers you're going to use. For area, you're never going to use the two that are not parallel to each other. You only use the parallel sides. So when you're looking down here at this problem, it's going to be area equals 1/2 times. Which one is the height out of those four numbers? Which one is the height? Which one is at a right angle to the two bases? 4. The one that is at a right angle to the two bases is going to be the 4. It doesn't have to be a dashed line, as long as it's a right angle to the two bases. And then what are your two bases that go inside your parentheses? 6 plus 7. Now listen to me. Your calculator is very smart. If you type this wrong, it's going to put the wrong answer. I suggest strongly not trying to deal with the parentheses. I suggest that you start by adding these together separately first. Now you can type it straight through, but people are going to mess up these parentheses. I suggest you do this. What's 6 plus 7? 13. Then you type it through on the calculator. 1/2, which I would type since we're rounding to as 0.5, times 4 times 13. 0.5 times 4 times 13. And what do you get? 26. And that would be meters squared because we're talking about area. Okay. Any concerns, questions? Again, you will have this formula you will be given on the day of the test. All you got to do is be able to plug into it. Okay, let's do the next one. So the next one's going to be area equals 1/2 times which number is your height? 8.4 is the height in this one, times your two bases, which the only other two numbers are going to be your base 1 and base 2, so 11.8 plus 6.3. It does not make any difference which one of those two numbers you put first. Doesn't matter at all. I would add first. What do you get when you add 11.8 and 6.3? 18.1. Okay. Then multiply it all together, all as one big problem. Multiply that all together. It surprised me. Surprised me on the answer. So I made the key already to this. What'd y'all get for an answer? 76. Isn't it 76? Like just 76?
76.02.
But it rounds off, so it ends up just being 76. So 76, what is it, meters squared. 76.02 rounds just to 76.0, which is just 7. Now, guys, can you write 76.0? Yes, I'll take it because it says rounding it. But if you write 76, that's the same thing. I don't care. Okay. Any questions or concerns? Because I don't have a lot of going forward on these because it's just you have the formula, all you do is plug in the numbers. I have some more going backwards because that's a little more complicated. Okay, here we go. The backwards, the other shape that we have today are rhombi and kites. Guys, this is a rhombus. All a rhombus is a parallelogram that has all the sides the same. Remember that. The rhombus is just going to be a parallelogram where all the sides are the same. This is a kite. Kite has two sides the same up here and two sides the same down here. Okay? They share an area formula. Rhombi and kites share the same area formula. It's 1/2, it's an easy formula, it's kind of nice. 1/2 diagonal 1 times diagonal 2. It is not given on the formula sheet. This one you have to know. Not on formula sheet. On formula sheet. Just so we're clear, this one is not on the formula sheet. This one is not on the formula sheet. You've got to know this one. 1/2 diagonal 1 times diagonal 2. The nice thing is it's pretty easy. Guys, you're multiplying the diagonals. Multiplying the diagonals. 1/2 diagonal 1 times diagonal 2. Okay, guys, so here we go. First things first. This is a rhombus. We're going to take and do area equals 1/2. And we're going to look for diagonal 1. Diagonal 1 is going to be this distance all the way across. It doesn't matter which one you do first, guys. However, all they've given you is half of it. If this is 6, this side is also going to be 6, which means your diagonal all the way across is going to be a total of 12. So when you plug it in, it's going to be 1/2 times 12. And then the other diagonal is going to go this way. And if it's 4 down here, it's going to be 4 up here, which means this entire diagonal is going to be 8. So it's going to be 1/2 times 12 times 8. 1/2 times 12 times 8. What does that give you for our final answer? What was it? I'm sorry. 48 meters squared. Area is always square units, so make sure you put that on there. 48 meters squared. Good. Okay, same thing on the next one. This is a kite, however, but guys, the same formula applies to both of them. It is a kite. So, 1/2 times diagonal 1 times diagonal 2. But we can't tell what the diagonals are until we add up the pieces. If we add up the pieces going from left to right horizontally, we'd be adding up 4.3 and 6.5. Add those together, tell me what you get for that first diagonal. What's that give you guys? What was it? 10.8. Okay. We're going to do the same thing going up and down. Going up and down, those amounts happen to be the same amount. What we're adding together is the 3.1 and the 3.1. What's 3.1 and 3.1? 6.2. There we go. So these are the diagonals you're going to plug into the problem. 1/2 diagonal 1, which is 10.8, times diagonal 2, which is 6.2. It does not matter what order you multiply these in at all. You can put the 6.2 first and it gives you the exact same answer. Multiplication can be switched. Doesn't matter. What's it give you? 33.48. So what'd that round to? 33.5 meters squared. If it's 33.48, it would be 33.5 meters squared, which is what I had. Nice. Okay, guys. So those are the examples of the direct going forward. There's going to be some backwards and then some special right triangle stuff to make sure that we know what we're doing on some old stuff going to be applied. Guys, they're going to keep putting old stuff into this new stuff. You're going to have to know how to do it. They're going to put Pythagorean theorem in there. They're going to put special right triangles in there. All that stuff from the last test is going to keep randomly showing up. So it's coming up in a second in these notes. Okay, this is a backwards problem. It says the area of a kite is this. So before you do anything, write the formula for the area of a kite. Area equals 1/2 times diagonal 1 times diagonal 2. The very first thing you do when you're working backwards is write the formula. Okay, it says the area is 92. So where the A is, you put a 92 equals, you bring down the 1/2. And then it says one of the diagonals is 22. So, guys, the first diagonal we're going to write as 22. Find the other diagonal. If it says find the other one, we're going to leave it as a variable. So we're going to leave it as D2. Diagonal 2. Okay, this is a regular equation. We've been solving these equations all year. Guys, you're going to start by multiplying the 1/2 times, ooh, that is too small. Hold on. We're going to multiply that 1/2 times that 22. What is half of 22? Multiply that first. It's 11. And then how are we going to get rid of this multiplication of the number with the variable? Divide. What are we going to divide both sides by? 11. We're going to divide both sides by 11 in order to cancel that out. The whole goal is to find out what the other diagonal is, which is what we're going to do right here. Now you're going to take your calculator and you're going to type it as 92 divided by 11, because we need to round it to the nearest tenth. 92 divided by 11, what's it give you rounded to one decimal place? Okay, so then what would that be rounded? 8.4 inches. Now, guys, we went backwards. It's no longer square. We're not talking about area. We're talking about the length of one of the diagonals, so it's just inches. 8.4 inches. Nicely done, guys. Alright, the next one is the same exact concept, only instead of dealing with a kite, we are dealing with a trapezoid. So this is the longer formula. This is one people tend to have issues with. I'm telling you up front, if you're given the formula, guys, you just got to be able to plug into it. Here's the formula. It's a Chris. I didn't turn it off. It's making noise from somewhere. Area equals 1/2 times height times base 1 plus base 2. I love that little smile. Okay. So what goes where the A is? That's the 177 equals 1/2. Do they give us the heights? 13? Yep. 13. Do they give us one of the bases? Yes, it is 11. And then base 2 is right here. And just like any other equation, you got to solve it by dealing with what you can first. We're going to take half of 13 first. That's something that we can do right now, is actually go ahead and find out what that is. We want half of 13. 6.5. Guys, we're working with decimals or rounding. Just put the 1/2 in as 0.5. It'll make your life easier. Okay? Now, this is multiplication. How do you get rid of multiplication? What's the opposite of multiplying? We're going to divide both sides by 6.5. Get rid of that 6.5. Now, I think this is an ugly number, so you're going to have to round it to 2 decimal places because we're in the problem. It's like 27? 27 point what? I need 2 decimal places. 0.23 equals 11 plus B2. So I've canceled that out. What's my last step? I only got one more step. How do I get that 11 to the other side? Subtract it. Subtract 11, subtract 11. Y'all tell me what B2 is equal to. Now, 1 decimal place because it's the final answer. So it'd be 16 point what? 2. 16.2, and it would be centimeters. Perfect. Centimeters. Nicely done. Guys, the backwards problems are not going away. They're going to be on the test. You got to know how to plug into a formula and go backwards. The EOC loves to ask questions on area backwards. They don't like to ask it going forward, so be aware. You're definitely going to see some of this. It's definitely going to be on there. Okay. The last thing that we're going to deal with, is there one more slide? Okay. The last thing we're going to deal with is old stuff coming up into this new stuff. 30, 60, 90, 45, 45, 90 triangles. Those magic numbers don't go away, guys. We're going to keep using them. So, here we go. Okay. So, for this one, find the area of each rhombus. This rhombus has one side on here. It also says this angle is 30. If this angle is 30 though, guys, this angle is also 30. The angle at the middle, those angles are always going to be 90 because these are going to be perpendicular to each other. And if it's 30 and 90, this one down here is going to be 60. So we have a 30, 60, 90 triangle. I'm going to draw it out here just so you can see it really clearly, the triangle by itself without all that other stuff. This is 3, this is the 90, this is the 60, this is the 30. Okay. Guys, if this one is 3 right here, pause for a second, look. If this one is 3, then what's the one up here? It's going to be 3. So this diagonal we've got, this diagonal 6, 3 plus 3 makes that diagonal 6. What we're going to use the 30, 60, 90 for is to find the diagonal that goes this way. So what we're looking for is this piece right here. That's the same as this piece right here in the picture. Okay? That means I'm going from the short leg to the long leg of a 30, 60, 90. What do you multiply by when you go from the short leg to the long leg of a 30, 60, 90? Radical 3. Okay, grab your calculators because this is decimal time because we need it to be an actual number. So do 3 times second square root 3 equals. 3 times second square root 3 equals. It's going to have to go to 2 decimal places. I think it rounds weird. Huh? You need to know how to type it? 3 equals. Second square root 3 equals. Got it? It's like 5 point, is it 19? Is it 196? Thank you. 5.196. Now guys, a 9 with a 6 after it is going to round up. But when you round the 9 up, it's really going to make it into 5 point what? 2. It's going to make it into 5.2. And if this one is 5.2, then this side is also 5.2, which means the length of this whole thing is going to be 10 point what? 4. Perfect. 10.4. Up till there, just on the 30, 60, 90 stuff. Does anybody have any questions? Guys, it's old stuff. They expect you to remember those magic numbers. They're not going away. They're going to keep showing up. They're going to be on your test. Be careful. So, find the area of that. It's just 1/2 diagonal 1, which is 10.4, times diagonal 2, which is 6. 1/2 diagonal 1 times diagonal 2. So 1/2 diagonal 1 times diagonal 2 would be around 31 point what? Thank you. 31.2, and that would be meters squared. Y'all agree with the 31.2? I just didn't get any confirmation. Yeah? Yes or no? Okay, just making sure. Usually I get confirmation. Just want to make sure. Okay. Last one. Is this the last one? Last one today is going to be the same idea, except instead of doing a 30, 60, 90 triangle, now you've got a 45, 45, 90 triangle. How do you know? Because the angles in the middle of a rhombus are going to be perpendicular, which means they're going to be right angles. And if this angle at the top is 45, then this angle at the bottom is also going to be 45. Guys, what do you know about the legs in a 45, 45, 90 triangle? They're what? Okay, hold on. I got different answers. Guys, if one leg of a 45, 45, 90 triangle is 5, what is the other leg? 5. It's got to be the same. They got to be congruent. I've heard different things, but I think I got the same answer. I just want to make sure. And if this one's 5, then this one's also going to be 5. If this one's 5, this one's also going to be 5. What shape is this, guys? Square. A square has 45, 45, 90 triangles in it, and all of them are going to be the same. That is a square. So, diagonal 1 going this way is going to be how long? 10. Diagonal 2 going this way is going to be how long? The same, 10. So, area is going to be equal to 1/2 diagonal 1, which is 10, times diagonal 2, which is going to be 10. And what's 1/2 diagonal 1 times diagonal 2? What was it? 50? And that would be meters squared. Good deal. Okay, guys, that's your notes for today. Let's see if we can apply it to actual shapes. Get you working on this.